Manufacturing in Shenzhen is around every corner. And on this day, I took a tour of a printed circuit board or PCB factory and a light emitting diode or LED factory, both in the Bao'an neighborhood. I'm Becky Stern, and this is Made in Shenzhen. We met up with Elaine to take a tour of one of PCBWay's factories. Aqua, David, and Ruth were there too. You might remember them from the last episode. Aqua helped us find Elaine once we arrived, who told us the main office is in Hangzhou, and that this is just one of their smaller factories. Elaine radiates positivity and enthusiasm for her work.
The delivery guy knocking the door and PCB, here comes to PCB package. I think that's the thrilling part of me. For me, it's a thrilling part of me to see this thing.
We were given the full red carpet welcome treatment with lanyards, flags, a banner, and our names on the office welcome screen.
Hi, welcome.
As we ventured onto the factory floor, we donned protective booties. But at this point, it wasn't clear if they were meant to protect my shoes from the factory or to protect the factory from my shoes. I'm sure I would get over it if I did it every day, but using the dispenser was pretty fun. First, the copper-plated fiberglass material is cut to size to fit the rest of the machinery. The corners can be quite sharp, so another machine rounds the corners of these smaller panels so they are safer to handle throughout the rest of the process. Next up, we entered the drilling room, where I promptly tripped the safety sensor exactly as Elaine was trying to explain how not to trip the safety sensor. These gigantic machines drill holes in the circuit boards while they're sandwiched in between two layers of sheet metal.
I learned that they put this metal they sandwich the metal over the PCB to prevent tear out when it's doing the drilling.
Yeah. I think it's really interesting seeing how it changes drill bit, and it's quite mesmerizing, really.
The next machinery line we were introduced to is responsible for plating the through holes, which electrically connect one side of the board to the other. This is a chemical process where the boards are dipped in a series of liquid baths, some of which contain a copper solution. A huge mechanical arm shuffles the baskets between the baths in an elaborate dance. I kept my arms away from the safety sensor this time.
You can smell both the copper and the sulfur.
Yeah.
I like how it agitates them back and forth.
At the end of the line, the whole basket and its contents end up plated in copper. The next room in the factory required us to put on special suits to protect the PCBs from our dust and hair, then get blasted with air to remove any loose particles.
Do you remember those Intel commercials from the 2000s with all the people in the chip fab doing the dances?
Yeah.
I feel like
That's us.
yeah.
The boards are coated in etch-resistant photosensitive material and then exposed to UV light with your design in between. The coating that's exposed to the UV light is hardened, and the rest of it is not and then can be removed. Then the board is run through the first etching process, which removes the copper plating from everywhere that wasn't previously protected. The etching process looks a lot like the plating process. After etching, the board has to be checked for etching errors. Sometimes the copper's not etched away completely where it should be. A machine uses cameras to check for these errors, then a worker fixes them by scratching away the excess copper. Next up is the solder mask, which is the protective coating that gives most PCBs their main color. It's applied using a silkscreen. Just like in AOI, they've got an automated line for large quantity orders, but it's hard to see what's going on inside those machines. For small orders, they have a more manual process that's easier to see.
There, they put the green on the circuit board.
That's how it gets the green on it.
Yeah.
Solder mask is applied to everywhere on the circuit board that doesn't touch components. That way, when they go through a solder reflow oven, the solder stays where it's supposed to. It comes in different colors than just green, too. After printing, the boards are spaced out in racks and baked in an oven to cure and harden the coating. Once the solder mask is cured, the board's artwork is added, also using a silkscreen process.
There's a lot of like namespace collision.
I think this layer gets to be called the silkscreen layer because it serves no functional electrical purpose. Solder mask serves an important function, so that function becomes the name. The so-called silkscreen layer is just artwork. It's the contrasting text layer containing reference labels, logos, polarity markings, and whatever else you want your board to visually communicate. The boards go through a final test before packaging and sending them to the customer. For orders under a certain quantity, a flying probe test machine is used to check the connections. It's like a big multimeter, moving its probes around to test whether every pad is connected the way it should be.
Test.
The probes pop around with incredible precision.
Look, it's got this big stone in it. You think that's like ballast so that because
to dampen vibrations.
Yeah.
For larger orders, the factory makes a custom test jig specific to that design. Instead of checking points one by one, the jig presses onto the entire board and tests everything at once. At this point, the boards are still part of large panels. The final step is separating them into individual units. The machines look a lot like the drilling machines from earlier, but they're configured to cut along a path to free each board from the panel. Behind the PCB, there's a spoil board, a sacrificial backing layer. You can see grooves carved into it from previous runs. Simple, right? Just a few steps to make a circuit board. To me, one of the most impressive aspects of the process is the precision required to line up the boards at each step. Not just the optical sensors that read the markers, but the complex software tool chains required to translate the different layers of your Gerber file into machine instructions that are all executed perfectly enough to generate a finished PCB. Elaine explained to me that China's reputation for manufacturing has been changing rapidly, in large part due to Shenzhen's electronics industry.
Shenzhen is not just about the low quality and the low cost, So today, I will say Shenzhen is everything about like the high quality and the innovation. It's not just one way. We collaborate and we do something together.
After lunch, we headed over to the pink-purple LED factory for a tour Aqua had set up for us. They showed us their product catalog, which includes many multicolor LEDs and addressable pixels with ICs.
This is very cool how this works. They have, so you see how it's like round there. So they have the wafer of LEDs, and then they put it in a saw, and it chops the individual dies apart, and then they put it on this stretchy membrane, and then they stretch the membrane apart, and that's how it separates all the little ones that have been chopped apart.
And then that's picking them up and putting them inside.
And this puts it inside the lead frame.
It's called a die attach, right? Die bonding.
They don't make these dies. They buy that part from another company. The next step is wire bonding, which attaches a tiny wire inside between the die and the contact in the lead frame. Each machine in the line only bonds one of these 3 wires in these RGB LEDs at a time, so the LEDs must be processed by multiple machines before this step is complete. Then it's on to the epoxy machine, which fills up the lead frame and helps hold everything together as one unit. Something else that's happening in this room is the application of a colored phosphor. Some LEDs get their color purely from their diode material, and some get their color from a combination of LED color and a phosphor on top that shifts that color. This whole time, the LEDs are stuck together in larger boards, just like the PCBs we saw earlier, and toted between machines in these metal racks. After being filled with epoxy, the LEDs are baked in an oven to cure. Check out the current draw on this oven. They send out the LEDs for the next step. They don't handle their own packaging. They rely on a nearby subcontractor for that step. The LEDs are separated from their larger sheets and sealed inside a plastic reel, which will prep them for the feeders of the assembly machines. They also showed us their extremely fancy spectrum analyzer, which is used to test a sample percentage of the LEDs to be sure they're putting off the right wavelengths. The last thing they showed us was their homemade test and demo jig that can show off all their different form factors. Pogo pins sideways. That's pretty cool.
Smart.
I wonder who makes their PCBs.
Yeah. How many pieces do they make per day?
20 kk.
20,000.
Like a 20 billion?
Okay, 20 million. Yeah.
A day?
Yeah.
Wow.
Here you can see the
24
calculator.
hours?
Yeah.
24 hours?
Yes, 24 hours.
20 hours.
20 million LEDs
That's a lot of
per day.
LEDs.
I've only ever seen one of these in Animal Crossing. I really enjoyed following the electronic supply chain one level deeper. Once we stepped inside the PCBWay factory, I realized just how much human involvement there is inside what most of us think of as a completely automated process. I like this project because it lets me peek behind the curtain, making the invisible part of these processes tangible for you at home. In the extended cut of this episode of Made in Shenzhen, you'll get a longer, more detailed PCB factory walkthrough, my full conversation with Elaine, lunch with the folks from PCBWay, and we'll have tea at the Pink Purple LED factory, where they make 20 million LEDs every day. Next time, we'll head inside another PCB factory that does things a bit differently and see how the components of boards are assembled into a finished product. With this series, I'm trying to offer a realistic look at what it would actually take to build a complete domestic electronic supply chain. If we talk about reshoring manufacturing in the US, I'm trying to show what that would really entail. I've filmed far more than can fit into one YouTube video though, so I'm releasing extended cuts as Nebula Plus episodes. Nebula is a creator-run streaming platform where projects like this can exist in their fullest form. It's home to a growing collection of original and exclusive series, and it's completely ad-free. This more editorial-type video series thrives in a space where extended cuts can stand on their own. Nebula makes that possible, and signing up directly supports projects like this one. Right now is also a great time to join. Nebula is offering 50% off the annual plan, which brings it down to $30 for the year, or about $250 a month. So if you want to watch my Nebula Plus cuts of Made in Shenzhen, including this deep dive into PCB and LED manufacturing, as well as the first episode about the Huashangbei electronics market, scan the QR code on screen or head to the link in my description. I'll also put a direct link to this episode's extended cut so you can jump right in.